In this lesson, we'll discuss how to use Newton's law of cooling. Newton's law of cooling can be summarized in this equation shown here, where T sub 0 is the original temperature of the object, S is the constant temperature of the surrounding, and K is the cooling constant. The question reads, suppose the temperature of a cup of hot tea obeys Newton's law of cooling. If the tea has a temperature of 200 degrees Fahrenheit in a room that maintains a constant temperature of 69 degrees Fahrenheit and cools to 178 degrees Fahrenheit after 1 minute, determine when the tea reaches a temperature of 149 degrees Fahrenheit. The first thing that I want to do is underline the important information found in the question. We're told that at the very beginning, when T is equal to 0, the temperature is 200 degrees Fahrenheit. The surrounding is a constant 69 degrees Fahrenheit. The T cools to 178 after 1 minute, so that's a difference of 22 degrees Fahrenheit. Let's go ahead and substitute those values into the formula as they are. Let's begin by writing out the temperature at time t is equal to 69, which is the room temperature, that doesn't change, plus the initial temperature of 200 minus 69 times e raised to the power of kt. As you can see, this equation is pretty incomplete. We don't know the information about k, but we can find out what it is by substituting 178 into here and the fact that that happens in 1 minute into t. Let's go ahead and find out what k is. 178 is equal to 69 plus the difference between these two is 131 e raised to the power of k times 1. Multiplying k times 1 is simply k, so we have 178. I'll bring that term over, minus 69 is equal to 131 e to the power of k. Dividing both sides by 131, let's go ahead and use our calculator for this. 178 minus 69 divided by 131, and we get the following quotient. Now on the right side of this equation, that's gone. We only have e to the power of k. To get k, we ln both sides. So we ln this side, and we ln the side that has this division statement. 109 over 131. The ln and the e, they cancel out because ln is the same thing as saying log of base e, and we have e here. So these two become 1. We have k on the right side, and let's find out what the ln of this value is. It's equal to negative 0.1838. Negative 0.1838. Let me place that right there. Now, we will substitute that value right into k, because by substituting it into k, we can find out what the question is actually asking us to do. Determine when the T reaches a temperature of 146 degrees Fahrenheit. Let me show you what all that means. We need to find the time when 146 is reached. So I'll place 146 into this place. 69 plus 131 e, and remember k was negative 0.1838. And now we're looking for the time. So we do the same algebra as before, 146 minus 69 divided by 131 is equal to e to the power of negative 0.1838 t. Ln both sides, that gets rid of that part. Ln of 146 minus 69 divided by 131. That's what's on the left side. On the right side, what remains is negative 0.1838 t and negative 0.53139 on the other. Divide both sides by this number, and we should end up with the time. Okay, let's go ahead and use our calculator. Dividing this by negative 0.1838, and we get a time of 2.89 minutes. 2.89. They want the answer rounded to the nearest minute, so it'll take 3 minutes for the temperature of this tea to go from 200 Fahrenheit to 146 degrees Fahrenheit. And there you have it. That is how to use Newton's law of cooling.